Despite substantial evidence to the contrary, there are many people that are still claiming that polyunsaturated fatty acids, PUFAs, are beneficial for health and pose no long-term health risks with increased consumption. So in today's video, let's analyze this whole PUFA debate with a unique perspective. So let's explore the effects of a higher PUFA diet on the health of livestock like chickens and pigs. Understanding these impacts may lead you to question the potential consequences of our own rising PUFA intake on human health. So my name is Farmer Ash, and I'm so fortunate to have the opportunity to combine my passions: metabolic health, fatty acid consumption, and regenerative agriculture here at Nourish and Angel Acres. So we strive to produce food how it used to be produced before the large change in the conventional agriculture system, with small-scale farm partners, custom-made low PUFA corn and soy-free feed to provide the highest quality low PUFA food you can find to optimize your metabolic health. So make sure you hit that like and subscribe button to follow along this journey, and check out our websites, which are linked below, to get a better idea of what we're about. And from there, you can join our food club to access the food that we produce. So before we dive in, I think it's important to discuss, what do livestock eat? So chickens and pigs are monogastric animals like us, so single stomach, and they require a supplemental feed even if they're raised out on pasture. So chickens and pigs cannot be 100% grass-fed. Over the last 70 years or so, we haven't just seen a significant change in our own human diets, like replacing saturated fat-rich butter with polyunsaturated PUFA-rich margarine. We've also seen a huge change in the feed ingredients used for livestock, which we then consume indirectly, because remember, you are what you eat eats. So the diets of animals directly impact the nutritional quality of meat, dairy, and eggs, which in turn impacts human health. So what are the livestock eating? Well, in today's landscape, the diets are high in omega-6 PUFAs derived from soybeans, corn, vegetable oil, canola oil, and biofuel products. Surprisingly, the majority of corn and soy grown in the US actually isn't consumed directly by humans, and a lot of it is used for livestock feed. So after World War II, corn and soybeans became the dominant row crops here. So acreage dedicated previously to, more diverse cropping system, smaller grains, different types of crops, well, those then became replaced by a lot of corn and soy fields, really transforming the agriculture system. Then technological advances in like hybridized seeds, GMOs, fertilizers, pesticides, and irrigation systems really boosted yields on corn and soy. So corn, for example, rose from 30 bushels per acre in the 1940s to now over 170 today. So this large shift to monoculture crop production has really reduced farm biodiversity and increased dependence on chemical inputs for pest control and soil fertility. And federal subsidies and crop insurance programs further support this industrial conventional agriculture model, prioritizing profits for large agribusiness companies over diversity and sustainability of small farms. Now, while this system produces abundant, low-cost, PUFA-rich food, it has led to declining food quality, environmental degradation, and adverse effects on both human and livestock health. So what prices are we really paying for the cheap food that this conventional agriculture system produces each year? So corn, soy, some other grains, vegetable oils, they're now very common feed ingredients. But an alarming new feed ingredient that isn't discussed much is something called dried distiller grains with solubles, DDGs. And this is far from ideal, and it's very high in PUFAs, unfortunately. So this new feed ingredient, DDGs, is a byproduct of a relatively new industry, the ethanol as fuel industry, which serves to be an alternative to gasoline. And it really surged in the early 2000s and was heavily influenced by government subsidies and policy support. So for every gallon of ethanol produced, approximately 2.6 kilograms of distiller grains are created. And in 2023, the U.S. ethanol industry produced approximately 35 million metric tons of distiller grains, which is 77.16 billion pounds. So how is DDGS made and why is it so high in PUFAs? So corn is the primary crop used for ethanol production. And corn contains a lot of starch, which is not bad for livestock, but the starch is removed in this process. So corn contains starch, fiber, fat, protein, and minerals. The ethanol industry needs the starch component. So corn undergoes fermentation to convert that starch content into ethanol and carbon dioxide. And then the remaining components, the protein, fiber, fat, and minerals, are then concentrated, dried, and then sold as DDGS as a feed ingredient. So since the starch is removed during that ethanol production, the remaining components, the non-fermentable components like the protein and fat, are left in higher concentrations. So this means that DDGS contains more fat and more PUFAs than the raw corn kernels itself. However, these PUFAs are highly prone to lipid peroxidation, and research confirms that DDGS contain elevated levels of lipid oxidation products, LOPs, due to the heating process used for drying because PUFAs are unstable and they can oxidize under heat. However, there are a number of other problems. So beyond lipid oxidation, DDGS often contains high levels of toxic agrochemicals. So most GMO corn used for ethanol production is heavily treated with herbicides, insecticides, and fungicides, such as glyphosate and atrazine. And so during ethanol production, those toxic residues actually become concentrated in the DDGS as the starch is removed while other components like the pesticides remain. So studies show that pesticide levels in DDGS can be significantly higher than in the original corn grain, posing risks to both livestock and environmental health. So while it is pretty standard in the livestock industry that feed formulations are proprietary information, it is well established that the DDGS is widely used in hog feed, meat bird, so broiler chicken feed, egg layer feed, and even fed to beef cattle, which will be a topic for another video. So DDGS is a cheap feed ingredient, often priced below 10 cents per pound, which is pretty cheap. And it does provide protein and fiber, making it attractive for livestock feed formulations. So it's widely used, but it does bring about the higher PUFA content in the livestock diet. So, for example, Tyson Foods, the largest chicken producer in the US, began incorporating DDGS into their poultry feed formulations in April 2004. And by 2010, the company was using approximately 700,000 metric tons. Each ton is 2,000 pounds. 700,000 metric tons of DDGS annually across all of its feed mills to produce chicken feed. So that was 2010. Imagine what that number looks like today in 2024. So while DDGS may be cost effective, it may keep the costs of products low, which then leads to final costs for food lower. It does come with hidden costs. It delivers high levels of PUFAs and pesticides to livestock diets, which can impact animal health, meat quality, and the food system at large. So as I've detailed in previous other videos and articles, pigs and chickens are quite literally a reflection of what they eat. So neither animals nor humans can produce polyunsaturated fatty acids inside of us. So that's why they're seen as, quote, essential. But the essentiality was shown with very small quantities. More is not merrier here. So the fat composition in the bodies of chickens and pigs reflects the fats that they consume in their diet. So PUFA levels in pork and chicken are entirely determined by the diets provided to them. Modern chicken and pork products now contain significantly higher levels of PUFAs compared to those from past generations, and a key contributor to this shift is the inclusion of higher PUFA feed ingredients like corn, soy, but also DDGS. So DDGS, since it's high in PUFAs, directly impacts the fat composition of the animals, and it's well documented in the literature as DDGS levels in feed increase, the linoleic acid and omega-6 PUFA, the linoleic acid content in pork fat rises while the saturated fat content declines. This is not what we want to see. So the nutritional profile of pork and chicken is now largely shaped by feed formulations, a really critical point to consider when we're evaluating the health implications of consuming these products. So pork fat from pigs fed DDGs can actually contain the same amount of PUFAs as canola oil. So the fatty acid concentration of pork fat has drastically changed. So clearly a diet higher in PUFAs changes the fatty acid composition of livestock fat tissues, but are there health consequences to a diet higher in PUFAs for these livestock? Yes. So PUFAs are unstable molecules prone to oxidation when exposed to heat, light, reactive oxygen species, or heavy metals. So this process, known as lipid peroxidation, it induces metabolic oxidative stress and produces toxic byproducts such as MDA, T-bars, 4-HNE, and these are well documented to cause a whole host of chronic disease and issues actually serve as biomarkers for lipid peroxidation inside the body. So lipid peroxidation from these PUFAs can occur during feed processing, so before the animals eat the feed. And that means that the livestock are consuming oxidized fats because, when these feed ingredients, they're exposed to oxygen, heat, while being made into the feed. And then it can also occur within the animal's body during digestion because, warm oxygen and heavy metals, there are plenty of conditions inside the body that can increase chances of oxidation as well. So these oxidation products have significant health implications. So let's dive in. First, gut health disruption. So this is also documented in humans, but in chickens, diets containing soy have been shown to cause dysbiosis and an overgrowth of pathogenic bacteria, such as Campylobacter and Acinetobacter. And conversely, soy-free diets actually promoted greater microbiome diversity. Oxidized soybean oil consumption has also led to tissue damage in the small intestine for meat birds. So in chickens, higher PUFA diets has shown to cause disruption in the digestive machinery and then also dysbiosis and a bacteria imbalance in their digestive tract. In hogs, the consumption of heat-treated soybean oil impaired small intestine growth, reduced nutrient absorption, and increased oxidative stress markers like MDA, while reducing their total antioxidant capacity. So here's a quote from the literature. Quote, "Previous studies have found that feeding oxidized lipids may negatively affect nutrient digestibility and utilization in animals due to localized oxidative damage to the intestinal epithelial cells." Ringzase et al. 2007 reported that feeding pigs oxidized sunflower oil, which contains high levels of linoleic acid similar to corn oil, increased T-bars in intestinal epithelial cells, which indicates an increased localized oxidative stress within the intestine. Additionally, Dibner et al. 1996 observed increased intestinal epithelial cell turnover and decreased lymphocyte proliferation in follicles of the lamina propria in broilers fed oxidized fat, indicating that nutrient absorption and digestion may be compromised due to the impairment of the intestinal cells. Quote, so damage from oxidation along the gut from diets higher in PUFAs, because PUFAs are more prone to oxidation due to their chemical structure. This can disrupt gut health and reduce nutrient absorption. Number 2, metabolic dysfunction. So similar to humans, high PUFA diets lead to more efficient fat gain with fewer calories due to the metabolic and hormonal effects of PUFAs. So here's a quote from Dr. Ray Peat, quote, "Linoleic and linolenic acids, the, quote, essential fatty acids and other polyunsaturated fatty acids, which are now fed to pigs to fatten them in the form of corn and soybeans, cause the animal's fat to be chemically equivalent to vegetable oil. In the late 1940s, chemical toxins were used to suppress the thyroid function of pigs to make them get fatter while consuming less food, because that's more profitable. When this was found to be carcinogenic, it was then found that corn and soybeans had the same anti-thyroid effect, causing the animals to be fattened at low cost. The animal's fat became chemically similar to the fats in their food, causing it to be equally toxic and equally fattening," end quote. Increased oxidation can interfere with very important metabolic functions in livestock. Number 3, endogenous antioxidant system impairment. Whew, that's a mouthful, but the body has a natural endogenous inside of us antioxidant system that can help protect the body by breaking down and removing free radicals, protecting us from excessive levels of oxidative stress, but to some degree. A diet high in PUFAs can hinder the body's endogenous antioxidant system, including lower levels of total superoxide dismutase, TSOD, and glutathione due to increased oxidative stress from lipid peroxidation. So with a high PUFA intake and higher levels of PUFA oxidation, higher levels of toxic byproducts like MDA, 4-HNE, those can be produced. And then these compounds place a heavy burden on the body's endogenous antioxidant system, which is responsible for neutralizing ROS and protecting cells from oxidative damage. So remember, PUFAs contain multiple double bonds, which make them more prone to oxidation compared to saturated fats. And so this process, lipid peroxidation, will generate these reactive oxygen species and lipid peroxidize. So then when these lipid peroxidation products then accumulate, the body's endogenous antioxidant systems like SOD, GSH, these are activated to neutralize these ROS and repair damage, but a diet unnaturally high in PUFAs can increase the load on these systems and potentially deplete antioxidant reserves over time. So if the demand exceeds the body's ability to regenerate these antioxidants, it then results in lower levels of the body's ability to protect itself. Quote, the enzyme activity of the natural antioxidant system was influenced by the degree of unsaturation of the diet, end quote. In one study, the chicken's natural antioxidant system was downregulated as the amount of DDGs, a high PUFA feed ingredient, was added to the diet, which was indicated by lower levels of SOD and GSH in tissues. Here's a table from another study, and as you can see, as DDGs is added to the diet in higher percentages, SOD and GSH activity is lower, indicating a PUFA's hindrance on the body's natural ability to protect itself. 4, brain damage. So high PUFA diets, especially linoleic acid, more than double the omega-6 fatty acid content in the chicken brain. These unstable fats oxidize, increasing levels of aldehydes like MDA in the plasma, liver, and brain. So sustained exposure to these lipid oxidation products can lead to a chronic oxidative stress state, which is going to damage cellular components. So in the research studies, maternal diets high in oxidized linoleic acid and low vitamin E caused accelerated neurological damage, ataxia, and encephalomysia in chick offspring. So it led to neurological damage in chicks when the mother chickens were eating diets higher in oxidized PUFAs. Lowering the maternal dietary linoleic acid or supplementing with high quantities of vitamin E was found to be protective. And so studies found these effects were due to the oxidized linoleic acid metabolites, oxalams, which can disrupt brain microvasculature and blood coagulation. Number 5, systemic oxidative damage. So the other points I've mentioned, the damage can cause disruption in various organ systems, but this happens systemically. Oxidized fats in the diet increase oxidative stress markers throughout the body. So in one study, chickens fed sunflower oil had elevated plasma and liver MDA levels. MDA is a oxalam. In another study, laying hens consuming oxidized vegetable oil experienced increased MDA in plasma and liver, increased rates of liver DNA damage, and follicle apoptosis. And then in another study, chickens fed oxidized vegetable oils increased T-bars in the plasma while reducing antioxidant levels, including vitamin E, across various tissues, because the higher your PUFA intake is, the more that vitamin E is used up. But the PUFA still stays there and is still susceptible to damage. So here's a quote from the literature, quote, the previous results could indicate that inclusion of thermally oxidized lipids independently of the origin in swine diets has a detrimental effect on the metabolic oxidative status of the animals measured by oxidative damage and specific endogenous antioxidants. In addition, vitamin E concentration in plasma or serum seems to decrease consistently in animals fed oxidized lipids and could be considered a good indicator of metabolic oxidative status in pigs, end quote. High levels of antioxidants like vitamin E are absolutely essential to add to high PUFA livestock feed to reduce PUFA oxidation. But again, these antioxidants can be kind of depleted during digestion, allowing further oxidation in other parts of the body. So clearly, there is substantial evidence pointing to the health consequences and metabolic stress caused by high PUFA diets. I just scratched the surface in today's video. And so this should raise concerns about the broader implications for human health. And if these issues are well documented in livestock, it's worth questioning the impact of similar dietary patterns on humans. Are we overlooking the real cost of high PUFA diets for both livestock and people? The conventional system persists because it is profitable. Agrobusinesses control the seeds used to produce these feed ingredients, and they control the toxic chemicals required to grow the crops, creating a self-sustaining and lucrative cycle. So the takeaway, unfortunately, a food industry centered on PUFAs has significant repercussions for both human and livestock health, and it wasn't always this way. There's been a big change in the agricultural system, so it's really time to question the cost of prioritizing profitability over quality of food products and long-term health. Now, corn and soy will undoubtedly remain a part of livestock feed, and to some extent that's acceptable. I'm not saying that they can't be included to some degree. However, the key lies in being mindful of the total PUFA intake for both livestock and in humans. We're now consuming PUFAs beyond what our bodies are designed to take care of and handle, right? It is not a case of the more the merrier when it comes to PUFAs. The heavy reliance on vitamin E supplementation in the livestock feed ingredients really highlights how these high PUFA diets require unnatural levels of antioxidants to mitigate the oxidative stress that they create. By using cheap byproducts from other industries like the ethanol industry and then subsidized crops like corn and soy, the price of conventional food products remain low. So it's important to consider that the reason that a lot of conventional food products are low is because their feed ingredients are so cheap, but these really come at the expense of quality. So if you are going to be consuming a lot of chicken products, pork products, egg products, I really strongly advise that you guys try to seek out low PUFA corn and soy-free options like we provide at Nourish. However, I completely understand that that's not always accessible or available. And so in those scenarios, prioritize meat from ruminant animals, such as beef or lamb. They contain a 4-chamber complex digestive system that can actually turn PUFAs into saturated fats to some degree. Now, scientists are coming up with ways to overcome that, and that'll be a topic for a future video. But these animals have naturally lower levels of PUFA in their fat, making them a better choice than conventional pork and chicken for minimizing your PUFA intake and promoting better health for yourself and for livestock. So here at Nourish and Angel Acres, we're not only passionate about producing low PUFA eggs and meat to improve your health, but we also really care about the health of our livestock too. Like, I love my ladies, my chickens, and I want to make sure that they are healthy as well. Healthier animals, healthier food, healthier humans, healthier environment, our goals here at Nourish, and it can be achieved by working with small-scale regenerative farmers, kind of opposite of what the centralized conventional ag system represents. So until next time, guys, I hope you stay nourished and enjoy the upcoming holiday season and delicious, nourishing meals with loved ones.